We tend to think about ourselves as humans, but this is only partly true. We are composed of trillions of human cells, but we are also made up of trillions of bacteria. These bacteria are part of us. They cover our entire skin and guts. Bacteria help us digest the food that we eat and protect us from intruders. But some bacteria have the potential to be harmful, causing diseases that risk human life and bring about suffering. So humans discovered antibiotics, and for a time, it was good. Antibiotics are produced by fungi and bacteria in nature, and were adapted by humans to be used as a medicine. Antibiotics are unlike most other medicines. They do not affect the activity of human cells. When exposed to antibiotics, only the bacteria die, while the human cells remain unharmed and the disease is cured. Antibiotics made once deadly diseases as harmless as having a cold. They have enabled many of the improvements in modern medicine, such as safe invasive surgeries and transplants. But look, some bacteria survived the antibiotic treatment. How did that happen? Let's look back. In the very beginning, even before the antibiotic exposure, some bacteria were already different. These bacteria had a resistance gene that protected the bacteria from the antibiotic. So, when the antibiotic was introduced, it did not kill the bacteria that had this gene. Instead, they survived. This is what we call antibiotic resistance, the resistance of some bacteria to antibiotics. But where did this resistance gene come from? How was this resistance gene there, even before the bacteria were exposed to antibiotics? Each time bacteria divide, their DNA undergoes random mutations. Most of these mutations are neutral or unrelated to antibiotics at all. But very rarely, one of these mutations can accidentally result in a resistance gene. Bacteria can also swap genes between themselves. Most of the time, these genes are not related to antibiotics at all. But very rarely, bacteria swap a resistance gene. Even though it is random and happens very rarely, because there are so many bacteria in the world, and because they divide so fast, every hour or less, for each antibiotic we create, there is already a resistance gene out there. What's more, because bacteria swap genes so frequently, this resistance gene can reach by chance disease-causing bacteria, making these diseases much harder to cure. These resistance genes appear and spread randomly, but each time we use antibiotics, we make these rare random events much more significant. The antibiotic kills most of the sensitive bacteria, leaving the resistant bacteria to survive and multiply, so their proportions in the population increase. This is what we call evolution of antibiotic resistance. These resistant bacteria can easily spread in the environment. So each time humans use antibiotics, resistant strains become more and more prevalent everywhere. How can we change this? We can use our growing knowledge about bacteria to make new drugs. These drugs could, for example, prevent harmful bacteria from causing a disease, but without killing them. So even when resistance to the drug appears, the resistant bacteria will not have an advantage compared to the sensitive ones, because all bacteria would have similar chances to survive and multiply. So the proportions of the drug-resistant bacteria will remain low. But what can we do now? We need to change the way we use antibiotics to limit their use to only when it is absolutely needed and in a minimal amount, so we can slow down the rise of resistant bacteria until new discoveries will come.